Well, we have a little bit of a warm up for how we kind of kick off these conversations, Molly, just to learn more about you beyond, your career story, and to get to know more about Molly as the person and the human being. And so, one of the things that we do, and this is something we do with our different peer groups, is ask people to share from a random object from around their environment with everyone. So, like for example. I don't have many objects with me because I've been driving across the country, but I have one important thing I wanted to share with you. It's my pothos plant, Eloise.
Nice. Hi, Eloise.
Eloise has made a cross-country journey. This is her second cross-country journey, so she's very, very experienced in navigating the road. However, she's had a little bit of a hard time on this trip because it's been so hot. It's been 99 degrees, and so my fiance and I are doing some plant rehabilitation. So we bring her inside with her. We bring her inside every time we come inside, and so she's got a couple leaves that got wilted when it was super hot through Kansas. So it's Eloise. She's like a spotted pothos plant.
Nice.
Very special to us. We got her when she was about this big. So.
Oh, she looks like she's on the mend. That's awesome.
Yeah. Yes, we've watered her and tried to restore her back to life. So she brings a lot of joy to the family and makes all of the adventures. So some people are crazy dog parents. Some people are crazy cat parents. I'm a crazy plant parent. So
that's awesome. That's awesome. Okay, well, I'm going to step away from my desk real quick to show you my thing, because I'm guessing that's where you're going with this, right? All right, I'll be right back.
Yes.
1 second.
Yes.
All right. This, I don't know if you can read the text. It's called Vishaka. But this is basically a layout. The first chip I ever worked on, actually the second chip, back when I started my engineering days, that I ever worked on, it was based on a project, which was a chassis-based networking system or switching system back in the early 2000s. And this was a port ASIC. And a port ASIC just means that it's like the ASIC that sits behind the Ethernet RJ45 Ethernet port. And this is basically just kind of like the actual printed layout of the ASIC itself, and then these are the actual prototypes. And the reason I have this is because I was in design verification, which is all about making sure your chip works as much as possible, at like it is as bugless as possible, so that way once it goes to the fab, you get a right chip the first time. Now, what this thing doesn't show is that the first chip we ever made, we forgot about a feature that we needed to test and verify. And so when the chip went to the fab and it came back, and then it went, we were like checking all of our things. And then it went to like true QA, where like you're testing functionality in like kind of a broader system. The QA engineer was like, so the specific part about Ethernet that you forgot to code into your chip doesn't work. And so we had to fix the code of our ASIC, retape out, and wait again for it to be fabricated, which is, anyone who's in the chip industry will know it's like super costly. So we got right ASIC on the first time, which meant that the verification process was successful. So that's something that I'm proud of. Yeah.
Wow, what a long, expensive QA cycle.
Yeah. I mean, that's the thing. It's like chip verification is probably the best thing to invest money into or tech into, because then you actually don't have to spend that money at the fab, which ends up being like 10x the cost at a minimum.
That's so special too that you have that plan. I love that. I've actually never seen a layout like that from a chip in the early stages of the cycle. So this is a first for me, and it's really special. One of the big emergent technologies with chip manufacturing now is like using AI to help with the layout, like what's the optimal physical layout as things get smaller and smaller. I can't imagine like manually designing the optimal layout for a chip. That is something that is beyond my comprehension.
Yeah, I mean, that was like a really specific skill set. You had place and route engineers who were looking at like computer design tools all day long, and like they had to like sit in a dark room basically to actually be able to see the contrast of the different layers on their computer screen, to know when to like connect things and stuff like that. So they were like, it was like the dark room is what we called it, but it was like 9 engineers that sat in a room that was totally pitch dark.